Good afternoon. Good afternoon, responsive audience. Some of you who were here at the 2 o'clock hour will surely feel that you are enjoying déjà vu. But out of respect for people who ultimately will be seeing these, at least in a recorded fashion, I do need to respect the formalities and turn the clock back and say a few words quite similar to what I said 2 hours ago. So forgive that, but it is important. We are here in Schollmeyer Hall and Walbacher Hall at the Fay Jones School of Architecture and Design on the campus of University of Arkansas to move further forward with our initiatives in timber and wood design and construction as a focus for the school in conceptual thinking, in material thinking, in societal, economic, even political thinking. In August of 2016, we hosted first a symposium here in Fayetteville, really introducing a number of educators, researchers, and architects to at least Northwest Arkansas, if not the state, people working to good effect in mass timber in particular, but across the timber and wood family of materials. And simultaneously, we organized and hosted a seminar in Little Rock together with Governor Hutchinson and Congressman Westerman, introducing investors, manufacturers, timberland owners, a number of actors in the Arkansas economic and environmental territory to the possibilities of economic development and even environmental benefit by working in the mass timber space. We are now 3.5 years beyond that August, and in December of last year, Structurlam, a Canadian-based manufacturer, announced that they will be moving forward with a CLT production facility in Conway, Arkansas. And we are here today to move forward with a new building for the school to be directly conceived and ultimately designed and constructed in timber and wood altogether. Things can in fact move quickly with enough dedication, enough commitment, enough enthusiasm, and this has truly been a collective effort on behalf of many in the school, many in the faculty, many of our staff, and certainly now many students over the last 3.5 years. For us to move forward as a campus, we have benefited from the support of Chancellor Steinmetz and Provost Coleman. You'll know that a year ago we opened the Library Annex building in the Windgate Art and Design District, the first mass timber building of its kind, of any kind in the state. And then this past August, we opened as a university the 700-bed, 200,000 square foot Adohi Hall. At this point, still the largest mass timber project in the country. And now we look ahead to a building for the school, the Anthony Timberlands Center for Design and Materials Innovation. And here too, we benefit as a school from the support of the Chancellor and the Provost. We benefit as well from the support of University Facilities Management, led by Mike Johnson. And in this particular regard, in this design competition, this exhibition, and all of the related activities at this stage in the process, we benefit very much from a substantial grant co-funded by the U.S. Forest Services and the U.S. Endowment for Forestry and Communities. This is what allows us to move into this competitive territory in order to bring such great finalists to the university and to the school. So there are many people to thank altogether, and we will be much, I think, to appreciate as we listen to presentations both this afternoon and again tomorrow afternoon. But to the matter at hand, in mid-fall last year, we sent out, together with University Facilities, a request for proposals for this 50,000 square foot, approximately $16.5 million building to be imagined and ultimately designed and constructed in timber and wood, not exclusively in mass timber, but taking advantage to the farthest extent possible of timber and wood products that could be sourced out of the state of Arkansas. We received 69 submittals, which, as you've heard before, is 4 times as many as a typical university project receives, twice as many as the largest previous project. And from those 69, we called 6 finalists who are with us today and tomorrow, and whose design entries are in the Smith Gallery. So, the future Anthony Timberlands Center for Design and Materials Innovation at the university is planned as an important extension of our school and as a key part of the university's Windgate Art and Design District, a campus district along Martin Luther King Jr. Boulevard that also houses existing and proposed buildings for the School of Art and the university libraries. This new applied research center will serve as the epicenter for our school's multiple timber and wood design initiatives. It will house the school's existing and expanding design build program and fabrication technologies laboratories, and further serve as the new home to the school's emerging graduate program in timber and wood design. The 6 finalists were selected based on the design excellence of the individual architect or practice at the national and even international level, as we will soon hear and see. And as well, the 6 finalists have demonstrated achievement in innovation with materials and construction. All 6 finalists are accomplished in both professional practice and architecture education. We are privileged today to hear from Dorte Mandrup, who visits us from her practice in Copenhagen, Denmark. Dorte Mandrup is, as a practice, it was founded in 1999 by creative director Dorte Mandrup, and the firm is, quote, driven by a devout belief in the possibilities of modern architecture and an experimental curiosity that insists on outstanding craftsmanship, end quote. With a particular attentiveness and respect for the peculiarities of locations and landscapes, their work is often inspired and shaped by its surroundings. The work of the practice emerges from a process of formal restlessness that materializes in deep contextual analysis and explorative prototyping. The practice has an extensive oeuvre of cultural, educational, workspace, and mixed-use buildings across Europe and North America. Selected works include the IKEA Hubholt Global Meeting Center in Malmö, Sweden, completed in 2015, the Wadden Sea Center in Ribe, Denmark, completed in 2017, and now the Icefjord Center in Ilulissat, Greenland, which is expected to be complete in 2021. The firm has been recognized with numerous awards, including the Finn Hjul Architectural Award in 2018, and the Trapreset Swedish Timber Prize in 2016. Dorte Mandrup has also served as the chairwoman of the jury for the Mies van der Rohe Award in 2019, among many other individual honors and leadership roles. Please welcome to our school and to this podium, Dorte Mandrup.
Thank you. Is it, yeah, can you hear me? Right. We're here together with Arab today, and Michelle will come up also and present the construction and sustainability strategy. First, a little bit about Dorte Mandrup and who we are. We work very much with site and materiality, and we also work a lot with sustainability. Sustainability is a very complex term, and what we have realized through the many years we've been working with it, that is definitely complicated, and there's no one right choice It all depends on a lot of parameters. We have life cycle analysis specialists sitting in the office. We have people looking at daylight. We have people looking at wind analysis and so forth. And there's so many parameters that you need to discuss and go through. So, of course, sustainability is not simple, but it's very urgent. But what we also say is that sustainability is urgent, and we need to take the right choices every time we do a building, because we do have a lot of impact on the CO2 footprint of being architects and doing buildings. But it can never substitute architecture in itself. We've been there for 20 years. What you see here is the IKEA headquarters in Malmö that actually had the prize of being the most sustainable office building in Northern Europe 3 years ago. And you can't see, this doesn't really look sustainable, doesn't have the sustainable kind of cliches, you could almost say. But it's all about envelope, it's about facade, it's about a lot of different things that you can practically not see. We are 63 people in the office for the moment, and we're from 10 different countries, including the United States. We like to have a global atmosphere in the office, even though that we think that we do stand on the Scandinavian tradition, or on the shoulders of the Scandinavian tradition. What you see here is the Isefjord Center in Ilulissat in Greenland. It's already almost finished, but it takes a long time because it's placed 300 kilometers north of the Arctic Circle, and it's almost impossible to build here during the winter time. So we spent twice as much time to build here. But sustainability with this project is also about how to ship material to this place, how to pack it into containers, how to assemble it without using too much machinery, and so forth and so forth. It's mainly a wood construction also, and it's prefabricated and shipped to Greenland, because there's no woods in Greenland. You can say, is that sustainable or is it not? To ship wood from Denmark to Greenland, but there's a lot of choices that you have to make all through this process, and that's what you need to work your way through. We think that sustainability also has to do with being in place and in a way also creating place where you are. So it has to do with reading the conditions around the place. It has to do with understanding your own role in comparison with time, you could say. This is the oldest landscape in the world, actually. This is where you discover that the Earth was, I don't know how many million years older. When you look at the rock here, it's bedrock, it's from the inside of the Earth. So being in place and somehow understanding your own role at what you are is part of being sustainable, and also part of, in a way, anchoring the building to the place and make it part of a local life. The Wadden Sea Center in Ribe is in Denmark, and this is all about materiality and history and landscape at the place. We're using locally harvested straw as a material that clads the whole building, both facades and roof. And somehow it has very much to do with the landscape. It doesn't have to do so much with choosing a certain material, but it has to do with choosing the right material for the right place at the right time. The Wadden Sea Center is another Wadden Sea Center. We were lucky enough to win 3 competitions along the Wadden Sea, Germany and Holland and Denmark. So this place is an old submarine harbor, and it's built on top of an old bunker, and it has to do with embracing or in a way pointing forward after World War II. It also has to do with relationship to the Wadden Sea, which is a UNESCO protected heritage landscape. Third Wadden Sea Center that we're doing right now is in Groningen in Holland, and this has to do with the tide, and it has to do with understanding the horizon and the lives of the seals around, but also it has to do with the industrial harbor and, in a way, giving back public space to and direct access to the water. The last competition that we've been winning and that we are doing right now, or doing the detailed drawings of, is the Whale, which is 300 kilometers north of the Arctic Circle in Norway. And this has a totally different materiality because it's a totally different place. And it's using local stones as a cladding on the shell of the roof. And it's a center for whales. Also, it has to do, of course, with a very specific place, and it has to do with the reading of the landscape. So coming to Arkansas. The Anthony Timberlands Center, Arkansas is a whole new place for us. So we've been trying to understand it, and maybe we have a little bit of a romantic reading of the place. But to me, I think there's a very unique, it's a very unique setting. You have, in a way, the feeling and the presence of wildlife and forest right around it. And for a Dane, and for a Scandinavian, especially for a Dane, that actually never really meets the real wildlife, this is a very exotic place to us. The landscape is lush with vitality, and it also has a climate that allows extreme temperatures and natural phenomena, like tornadoes and heavy flooding to hot and humid summers. The forest surrounds the town, and in a controlled way, it extends into the center of Fayetteville and the University of Arkansas. The immediacy of nature and climate has provided the region with what we think is embedded knowledge integrated into the culture. Located at the corner of Martin Luther King Jr. Boulevard and Government Avenue, the new Anthony Timberlands Center provides the new and unique opportunity to present innovation and the future of wood construction, but also to interpret the history and the understanding of wood in this unique region. The 5-floor building is a simple, tapering vessel defined by a double-layer diagrid facade that carries all vertical loads in the building. And this means that we have been looking to make a building that has no columns and no load-bearing walls to achieve as much flexibility now and in the future, but also in the process, together with the users and with the client, to actually be able to very freely make sure that all the functionality is placed in the right way, but also that you can change it over time. It's constructed out of glulam, and the lightweight construction significantly reduces the use of necessary material and uses traditional techniques with advanced milling techniques to create elegant connection details. So within the vessel, each level acts individually as a beam and spans from facade to facade, allowing for all floors to be free of columns and structural walls. So every floor has an interior beam spanning from facade to facade, and the outer beams here, of course, also spanning from facade to facade. And by doing that, we can avoid any kind of columns. So it's a very simple scheme. You have the vessel that is load-bearing, and then you have the floor spanning from side to side. At the center of the building, an open atrium extends from the fabrication floor to the roof terrace, like a clearing within a forest. So ascending the open atrium stair, visitors have uninterrupted views to the fabrication shop and to all the activities in the building. So you move up along the stair on the inside of the atrium all the way up. And by doing that, you will have both views to the activities on the floors, but also to the activities in the fabrication shop. It culminates in the rooftop forest that provides a 360-degree view overlooking Fayetteville and the Boston Mountains. The double height spaces create a spatial variation and provides the flexibility and potential for adding intermediate floors within the vessel, and hereby expanding the total area within the building volume. And this is, of course, to do with future expansion. So you have the possibility of adding extra floors into the double height spaces here, and by having no columns on here, you will also have the possibility of really making very large objects or high objects in the fabrication shop. The roof terrace here, we actually imagine as an arboretum where you can have Arkansas trees planted here, not only to show the Arkansas trees, but also to provide shadow and possibility of actually being on the rooftop in the summertime instead of having the sun burn you out. The prominent porch motif that you see in the vernacular Arkansas architecture is reimagined as a balcony zone between the facade layers. The pine cone, in a way, is opening up when it's losing its seeds, and we imagine the outer skin of the building to work like a pine cone. So you have an outer layer of single layer glass, very simple, very low tech, almost like a cladding that can open up, or like wood shingles but in glass. So by having this outer layer, you can in the summertime open it up to get air, but also you can slide the whole outer facade away, so you have a porch situation. And in the winter time, you can slide it back, and you will have an intermediate zone that is preheated by the sun. So the porch actually encircles the building and acts as a social space. So in the summertime, you could also just use it as a balcony space, not smoking, but drinking coffee. And also we imagine that the whole facade can be used as a tree nursery for trees, for small trees. And by doing that, we can actually show off the whole life cycle of the tree. There's also a potential to integrate planters in the flooring, or we can work with a much more minimal balcony construction, and that's all depending on the final usage. The porch and the wood structure is protected from the weather by the shingle glass, but can also be completely opened in the warm season. The building is flooded with daylight, and that is not only because we like daylight, but it's because there is documentation that people physically and mentally needs to have a certain amount of daylight, and if people are working here all day, it's actually a really important thing. I think that, I don't know about the States, but it would be illegal in Scandinavia to have any kind of workplaces that are not that doesn't have a certain amount of daylight, and that is because of health reasons. At the heart of the building is the fabrication shop, the epicenter of creating, learning, and knowledge sharing. Our intention is to create a space that encourages cross-pollination between disciplines and understandings. It is important that it's open, inviting, connected, and filled with daylight. It's also important that students feel that they are part of a community, and that the building supports informal meetings and learning situations that can be established everywhere. And that its structures and faculty are visible and available, and that work is in view and on display. And that's why we made the building very transparent and very permeable, so you will always be able to see what's going on the different floors, or from the different floors to the fabrication shop. The building embodies the complete life cycle of wood, starting from a sapling that grows on the porches of the building. And it showcases the handling and processing of wood from traditional techniques to advanced research and innovation, all in search of a sustainable future with wood at the forefront. The entrance is placed at the corner of Martin Luther King and Government Avenue here, and is directed towards both streets here. And then you have the fabrication yard here with the delivery in this end, because we think it's quite important that you don't cut off the connection between the art school and the fabrication shop here by lorries and trucks coming, and delivery and so forth. So the delivery is here, and the gantry crane is coming in this direction. The outer layer of glass is subtly folded out where we need more coverage. And here at the entrance, it's both marking the entrance, and it's also giving shelter and connection with the entrance, so you can actually be standing here, a group of people waiting, and not get wet. And it's raining here, like in Denmark. Passers-by will catch a glimpse of the fabrication shop or the adjacent collection of the latest completed projects on exhibit. Further along Government Avenue, pedestrians can see directly into the main hall of the fabrication shop. The 20-foot tall gantry crane is at work in the center of the space. Robotic arms are working on construction elements for a few building prototypes. So if we go through the plans, you enter either from Government Avenue here or Martin Luther King Jr. Boulevard. And so you can enter from both sides, and we imagine that the entrance space, together with the gathering stair here and the top floor here, is also an exhibition space, so that you use the space for many different uses, and the rest of the floor is actually the fabrication shop, with the possibility of having smaller spaces underneath the first floor, and building larger things in the middle here. So the floor height is at least 6 meters and higher. The fabrication shop is directly adjacent and to the entrance, and is column-free space with varying ceiling heights to allow for maximum flexibility. Since fabrication and machine design requirements are continuously changing, we suggest that we make custom enclosures to meet special space requirements, and that we actually work with the house-in-house method, which is building interior volumes within the larger space. And this allows for smooth, efficient transition of equipment. So this is also a subject that could be done in collaboration with the University of Arkansas, and it could be a very obvious student assignment, and very, in a way, could be part of the whole process. The gantry crane rail is supported by an independent construction, and that is to ensure that you can change it, that is not part of the building's construction, that it's independent, and you can change it, you can get another one, you can get a bigger one, whatever. So the house is not dependent on the crane. And it extends into the fabrication yard to ensure flexibility. In the fabrication yard, students can construct full-scale mock-ups in the open air, and large deliveries are made with ease via the loading dock. So you have a loading dock here. And the yard is in direct connection to the adjacent shared landscape and allows for effortless social connection and convenient communication for interdisciplinary projects with the art school. So, of course, we know this is not going to look like this. We just imagined a facade, but there's a big opportunity here to work together with the fabrication yard, to also open it up towards the art school and to use this space out here as a common space. On the second level, the exhibition space provides elevated views toward the action of the Fabrication Shop. Here, curated shows present the center's latest ideas and research to students and to the public. Satellite labs are also located on the second level with direct internal access to the main Fabrication Shop. The satellite labs are ideally located for constant visual communication with the main shop. So the access, the direct access is here. So you can move up here and you can actually also come down directly to the shop here. As the floor rotates and you move upward, students and visitors gain constant changing perspectives on the Fabrication Shop and the landscape beyond. The rotating floors introduce various spaces for collaboration and sharing knowledge. And what you see here is actually just to show that you can use the center of the space for large objects. The auditorium on the third floor looks west out of the landscape while still maintaining a clear view to the fabrication lab and to the shop and to the labs here. And here's a render of the auditorium and a kind of informal gathering in the corner of the auditorium. So you have a glass wall here towards the Fabrication Shop, and you see the inner constructions with the climate screen and the acoustic ceiling here. The design studios are located in the open atrium on the balcony on the fourth floor and are adjacent to the classrooms and the seminar rooms. The seminar rooms are flexible and can be operating as two smaller rooms or opening into one larger space. So you have the open design lab here, and you have more closed classrooms and seminar rooms here. On the fifth floor is a small library and the residence rooms in connection with the lower roof terrace that again has the auditorium stair leading to the roof or the top roof terrace. So this is a more informal gathering space. It could be used for events, of course, but also for education. And the top roof terrace with bigger trees on top here, and the views, of course, all the way around Fayetteville and Boston Mountains. The roof terrace is planted with trees to create shelter from the summer sun, as well as act as part of the rainwater collection system.
A little shorter, so I'll move this down. I'm Michelle Roloffs with AirUp, and I'll kind of take it from here. So as we're looking, from this view, you can really see how the building is a celebration of mass timber, and you can see from the outside the expression of the primary vertical and lateral load resisting system, which is this expressive diagrid on the outside, and that's intended to be made out of glulam construction. As you look at the section, you can start to see some of the other elements that we've already spoken about. So, sorry, I'm having a hard time seeing. There we go. So you can see a glulam truss here spanning from one side of our diagrid to the other. And then in section, this would be a similar truss, and where you can see these longer span floors, and it allows us to have these column-free spaces throughout the whole zone. And in these floors, the intention is that we would have a panelized timber system that is stiffened and strengthened by these diamond glulam beams that are bent and create an expressive soffit, so that you can really view the beauty of the timber. One thing to note about this is that it's not reliant on necessarily being cross-laminated timber, and we could also use other sorts of panelized timber systems like glulam on edge, dowel laminated timber, nail laminated timber, to construct these floors with the assist of these stiffening beams. And really all of the timber in the project can be made with simple glulam elements. The glulam beams do then cantilever out to support this thin timber facade. And so here's a location where you can potentially even use sawn lumber or other simple locally sourced Arkansas timber. And you can see it maybe a little bit more clearly here, where we have our beams cantilevering out to what would be this facade support. And there's a lot of articulation in this project. We're looking at a lot of individual elements, which is intentional so that we can use timber that can be locally sourced in Arkansas. But we also then need to think about how we can construct this in an efficient way. So if we zoom in kind of diagrammatically at one of a typical connection type, just to orient everyone to where we are. So this would be one of the diagrid elements. This is a joint where a diagrid element would be joining with a diagrid element below. This is one of the stiffening beams coming out, cantilevering out as a continuous element to then support what would be our sawn lumber backup facade support. And a couple things to unpack on this particular item. So one is that we're looking to, as a first step, offset all of our timber elements so that we can have simplified, simplified connection details. Instead of creating a very complex 3D node where all of the elements are coming in and trying to meet in one place, we're allowing the timber to kind of fly past. So these beams are flying past the glue lam support. It also means that we can have a continuous element that's cantilevering, so we're avoiding any sort of complex moment connections that are much more difficult to do in timber. And then if we look at each individual element, so for the diamond beams, this is something that's part of the expression of the interior. And there is some curvature to these elements, but the idea is that this is a singly curved beam that can then be turned on edge to stiffen the floor and really give a kind of beautiful expression. It's maybe harder to read in this particular image, but for the whole floor would be, a 45-foot package, which can then be, this whole curved element can be prefabricated in a factory, brought onto site, it already in its full length, and then you really are limiting your connections just to where it comes at each node point. It would be a similar strategy with the diagrid, where some of the complex zones where it comes together would be done in a factory setting, and then you use a more simplified connection in the field. And then one of the areas that we think would be a really interesting collaboration with the students and faculty here at the university is at the facade. So you can see here we've rendered just a very simple connection, but this is an area where we could really think about how we can engage with the community in developing a custom wood joinery connection there. So it's at a scale where we can really prototype full scale, with students here. We can partner with you to test out different ways to kind of look at the history of wood joinery, but then where can we take that to with the CNC technology that we have now? The same type of machines that we're going to have in this facility are the types of machines that we can use to actually mill some of these complex joints. So it's something that we would really like to look at collaboratively and have this kind of unique expression for this building that gets implemented. And thinking through to the construction, it would also be possible for that particular scale of item to bring a CNC machine to site to fabricate some of the elements, which could be visible to the community and to the university during construction, so you can really see what's happening. So we've zoomed in, and now let's maybe zoom back out and think a little bit more about the sustainability of this project. So, it's understood that this is a mass timber building, and I think we all understand, sorry, I'm getting some blowback. I think we all understand that this is a very sustainable material that we really want to showcase in this building. And we have the benefit by using mass timber and really expressing it to show how we're sequestering carbon through the use of timber, but also if utilizing local Arkansas timber means that we're minimizing some of our shipping and the carbon that's associated with transportation. So we're trying to keep this as local as possible, again with the decisions to use glue lam and sawn lumber. So one of the elements that we've talked a bit about is the covered porch area that surrounds the building. And this is something that we think is also important for our sustainability strategy. So we have a rain screen on the outside and our thermal barrier on the inside. And that provides us with this buffer zone, which won't be fully conditioned, and we'll use passive strategies to try to maintain a temperature there that can be comfortable for most of the year, certainly through the shoulder seasons, and then can also act as a buffer for the interior space where we're going to have a tighter set point for comfort and for the use of the space. And then, this section can vary and respond to the siting of the building. So for example, on the north facade, this could be reduced or potentially eliminated, where we really want to maximize daylight access and solar heat gain in the winter. While on the south facade, this zone may be more generous to provide more shading to reduce the heating loads in the summer. And then on the east, west, and south facades, there are a few ways that we could consider incorporating more shading into this space. So one could be with the facade materiality itself, but another solution would be using the nursery and the type of greenery that we choose to plant in different zones to create shading that can help reduce the glare in the morning and afternoon hours that can be difficult to deal with. And while we're looking at the nursery, I think we can also talk a bit about some rooftop rainwater harvesting. So, as is evidenced by today, there is a pretty consistent amount of precipitation in this region, which makes this project a good candidate for rainwater capture. And so if we use rooftop collection and then a gravity-fed system to the greenery to do the irrigation for our project, that both reduces the potable water demand on the project, but then also means that we aren't using energy to pump water up to irrigate these. So there's kind of a double benefit to that type of strategy. When we're looking at particularly the south, east, and west facades, there are some strategies that we could take to passively temper the space in the summer. So the first strategy is, of course, to try to block solar heat gain. So that can be done with the greenery that we were discussing, but also with deployable shades. This is another place where we think we could really collaborate with the university on coming up with some custom screening that could be deployed during the summertime, but also on the east and west facades to control glare. So we've taken this first step at reducing the solar gain, but then the next is through natural ventilation. So there's obviously the condition that we've talked about where it is just open on very comfortable days that we may want to employ. But even when you're not totally opening, you may still want wind or other sorts of protection. You can open at a low point and at a high point to create a single-sided natural ventilation strategy. And then, given that we have all 4 seasons here, we also need to think about what we might do to handle this space in the winter. So so that we can kind of extend the use of these balconies as a way for people to engage with the space and also to maintain plant life, would want to give some sort of heating to the space. But we have the benefit of the waste heat that we're getting from the building's air side system. So we can use the rejected heat to create a radiant floor system here. When you look at the program of the building, given the high shop and lab space demand, there's going to be a lot of demand for circulated air. So we think that one of the highest energy demands is actually going to be driven by outdoor air conditioning, or conditioning of outdoor air. So we propose in the first instance to decouple the outdoor air conditioning with a dedicated outdoor air unit from the local conditioning, which can be done by zonal fan coil units, active chill beams, and those types of solutions. But also, we can use some low-tech solutions that allow us to precondition some of the air before it reaches our mechanical equipment. So a Traum Wall is a pretty low-tech system, which is essentially just an enclosed kind of facade shaft where you allow your cold air to enter from the bottom. You use solar radiation to heat that air. By the time it gets into your equipment, it is already at a higher temperature. So you're not using as much energy to heat to the set point that you're looking for in the building. And then, one last idea on the sustainability front is to actually try to use the building to generate energy on site. And one way to do this would be with building integrated PVs. And there are products that can be transparent. And we have the benefit of our south facade having two separate orientations. So we have a more vertical orientation, which is better for generating energy in winter, and then a more horizontal orientation that is better for generating energy in the summer. And that ends up balancing so that you have a constant level of energy generation throughout the year. And so, this is a system where we may be able to generate, not completely offset the building, but a substantial portion. And I think that concludes. I'll let Dorte finish.
Thank you. And then I would like to finish by saying that this is, of course, a conceptual idea. The idea of the double layer facade. You have, of course, the inner climate screen with the 3-layer glass, and you have an outer climate screen, which is much more like very simple, non-technological, not airtight facade. So it's not to think of as more as a cladding, you could say, or a rain screen for the construction, as a real facade. But the idea is that you have this vessel, and that it has different possibilities. You can close off some parts of the inner facade. You could also maybe work with the outer facade with different materiality. And that is, in a way, has this kind of simplicity also in the interior with the no columns, that you have a lot of flexibility to actually work with this as much more as a collage idea. So it's not set design, but it's a conceptual design that is quite simple, but also strong enough to, in a way, withstand different ways of working with the interior and with both layers of facade. So yeah, thanks.
Okay, as before, I'll invite questions. Just for you in the audience to know, all of our finalists are spending their mornings in a committee interview, so we've asked quite a lot of questions of each of them, and this is really an opportunity for the larger school community to explore these ideas and these proposals. Yes.
Hi, my name is Max. I'm a student in landscape architecture. So I'm really curious, in either of your practices, what kind of opportunities for research or exploration drew you to this project originally? And then also, what experiences or explorations over the course of this project do you think will carry with you afterwards to inform later projects and later work?
The fact that there's a process here, if we continue here, there's a process, there's different processes. One of them is about functionality and how the whole building should actually function together with the different uses. And there's a process that is about the design of the building and of the and of parts of the building. I think there's a lot of opportunities to engage with the university and with students, but also with maybe the wider range of university. There's also knowledge to gain outside the architecture department. And I think that both Arab and I have planned a series of workshops that has different themes that would be obvious to work with the students. So I think that it's an ongoing process that would be following probably the way that you will work with the project in the office. So starting with the overall design and the functionality, but also working in a way with a more sort of sketchy process with the users, and then of course having specific design assignments together with the students and the faculty. So I think there's a lot of knowledge that we could bring in, but also a lot of knowledge that we could take out of the whole process. And I think that, as Michelle has also showed a little bit, there's different themes that are definitely worthwhile investigating, and that could be part of a research project. But was that an answer? Okay, right.
Yeah, a little bit about
Yeah,
the
you can.
joints.
Yeah.
So specifically with the timber joints that I was discussing, both myself personally and also Arab as a practice has been really interested in understanding how we can look at wood joinery differently now that we have more techniques available to us with the technology that we have. And so we've done some research using finite element modeling to look at some of these different types of joints, and I think that's the type of research we'd want to bring into that particular discussion, and then hopefully that really allows for more exploration in timber projects in the future of how you can bring timber pieces together with less less use of steel, or just a different application of how you implement other materials in those joints.
I think there's a lot of both technical research but also design research, I think, into this. And I think it's also about using wood maybe in different applications that you wouldn't see wood be used in. Usually it could be much more about making soft 3D materiality that I personally think would be really, really interesting. And I think we probably have different expertise to bring in. So I think there's a whole range from trying to use wood in a very different way to looking at wood joints.
Okay, another question. Yes, sir. You might be audible from where you stand, I think. Go ahead. Go ahead, give it a try.
My name is Russell. I teach in architecture, so I'm used to projecting in this space. My question is, thank you for the presentation.
Thank you.
And the clarity of some of the things we were talking about. Just, it's a summary question, really. I'm curious what is embodied in your proposal that excites you the most about what you brought us today?
Well, what actually excites me, well, there are two things. I think what really excites me is the opportunity to, I think, once again, understand an area and a building culture, and in a way trying to push that into the future. And I think that there's a lot of I think that the vessel that we have done has this kind of flexibility and possibility of evolving through the process, and that's what I would be looking forward to. Was that? Yeah, that was one thing.
Say something.
Yeah.
I think for me, at least, one of the things that's really exciting is the goal of using the timber locally sourced in Arkansas, and how we can adopt the design and work with the manufacturers and the industry here to really come up with something that can be primarily produced in the region.
And then, if I can add, I've been building in wood since my very first building, and I've been using very inexpensive wood like LVL and not cross-laminated timber, but kind of cheap structural timber, and try to make an architectural expression out of that. And I think that's that part of this project is very much about showing off timber, but also the inexpensive timber, right? So everybody can make really beautiful timber joints, but trying to also look into a more inexpensive way of making timber look amazing. Yeah.
Other questions? Yes, also well back in the corner, but someone who knows how to project.
No need. Can you hear me?
Yes?
I enjoyed your presentation. I I appreciate especially the sections of your building, given the anonymity of the surrounding. In the discussion of sustainability, you seem to be, if I understood you correctly, you seem to be suggesting that we could do this, or respond to a particular issue in a number of different ways. Was that correct?
I think there's a number of different possibilities, and I think part of the working with the project would be to prioritize this and also to prioritize where to close walls and where to open them up and so forth.
Okay.
It's kind of a frame. That you can in a way work with, and I think it's very much about optimizing the project and actually making the right choices.
That wasn't my question, actually,
Okay.
but I'm coming to it, but thanks for
Okay.
that response. I'm wondering if you, because of a variety of different ways that you've thought about responding to different environmental conditions with the double skin system, have you thought about monitoring the building, one as a way of tuning it, but also as possibly as a way of making it reflective of different environmental conditions through the year?
Yes, we have suggested also in the project that we use the monitoring of the different sustainability strategies and make it public and make it exhibited. So there's a possibility of also using it as a research object for the university. Was that the question? No? Yeah, it was. Yeah. Yeah. Okay.
Which is, yeah. I think the second part of that question was, are there ways that we can actually use the monitoring to change how we're adapting the space in a kind of smarter way? And so I think that, there's this balance between the high and low tech, right? But if, let's say, you have a monitoring system that's letting you know that it's time to go open up those shingles, we're not really proposing something that's truly kind of a mechanized system, but it could be something that alerts the operations of the building to actually, open or close the kind of natural ventilation. And then there are some things that, we didn't necessarily touch on in the presentation, but along with the rainwater capture, if we're capturing stormwater, there's smart monitoring systems where you can, if you have your stormwater tank and you know that a storm is coming, release some of that early so that you don't overflow your stormwater, your city stormwater system. So there are other sorts of, monitoring solutions that can change the way that you actually operate the building.
Yes, Justin. Please stand up and be recognized.
I'm Justin. I'm part of the fabrication team here and specifically oversee the wood fabrication elements. Really, I just wanted to comment and say that I appreciate the bold strategy and that you bring it with some flexibility to change things as you learn more about the needs of the region or of the school. And also that I appreciate the different scales of fabrication spaces. So the satellite fabrication spaces and then the main fabrication space and the flexibility of that, the house-in-house that you talked about. And so I don't really have any questions beyond that. But, yeah, thank you.
I will say I'll repeat a question which has come up in our committee discussions, which is to say, how would you go forward from this into, well, let's put it another way. Relative to the program, are there parts of the program that, in your view, seem superfluous and actually things, meaning not necessary?
Unnecessary.
Or parts of the program are that you would actually want to add in? And having said that, going forward, were you to receive this commission, how would you engage with the school to understand much more precisely the real programming that needs to be done?
Well, I don't know whether it's unnecessary, any of the program, because I would only know that, after working with but but when we usually, when we do programming, what we do is that we try to look for, too much space anywhere, because every user in the world will like to express their needs, but the whole idea of, in a way, trying to, that's also a sustainable way of working with the program, is to try to make every space usable for a lot of different things. And if I could say that one room that I might say could be unnecessary, and maybe I'm doing something wrong when I'm saying it, because I know maybe sponsors are coming in, but I think the auditorium might be a space that you could create much more relaxed around in the staircases, and maybe some of the classrooms. I think that there's much more need now in modern learning. There's much more need for being able to work everywhere, and actually using every space for everything. So yeah, and then going on, I think that again, one of the most important things is to be present, and also to be personally present when you do the first initial work with the program, and that you actually do that in a three-dimensional way, that you do drawings and physical models to try to understand what you actually, what is actually your main needs, and what is not necessary, but also you will discover maybe that there are needs that you didn't know you had. So I think that is kind of the first part of the process, and then I think there's the whole initial sketching part of the project that I would personally like to attend, me and the team, and then the workshops, of course, and the work with the faculty and students, and then I think there will be a team taking over also locally, but of course a team of constructing architects and the project architects from the office that would take more and more over. So that's how we think it will work.
Yeah, so in a follow-on question, again, were you to receive this commission, how would you're at a distance now, whether this is an exotic place or not, it's a new place for you to come to know and come to work in. How would you propose that you would work in order to be present and be part of the overall process and, in a way, cut down the space and distance?
Well, the project, the well in Norway, is further away than here. It's not further away in kilometers, but it's further away in time. And you just need to plan in a way so that you make the time, and you also make use of the time traveling. So I think that's not. I don't think the distance is a problem. I think that there's a planning, very thorough planning part of this with the time plan. And then, of course, there's always Skype. We have projects in Denmark that is mainly meetings on Skype, because even in this small country I'm from, the distance of 2 or 3 hours is wasted time sometime, and so we meet with our client every week on Skype. Works perfectly. So I don't think you necessarily need to be in person every week, but you need to be in close contact. But that doesn't have to be physical.
Yes, Brian.
Hi, I'm Brian Holland, the faculty member here. The question I have has to do with the exterior glazing. I wonder if you could say a few words about the need to balance the, what I presume is the desire for transparency to reveal the structure to the outside, and the need to control the solar glare. I'm thinking particularly about the need for the glazing to become somewhat reflective, perhaps either by solar gain needs or even code requirements.
Well, I think that when we get, if we get closer to the project, we will definitely work also with the solar gain much more directly, and we'll do calculations. And I'm sure that there will be places, both in the interior skin, where we would need to have insulated parts, and there would also maybe be a necessity for working with some of the shingles as closed shingles to reduce the glare. But then there's the whole in-between possibility of working with both plants, with the solar screening and so forth. So I think that's part of the investigation, also the interesting part of the investigation, to make the right choices here. To me, it's not the architectural point is not transparency. It's much more about reflecting the shingle tradition, you could say, in one way, but also being able to show the beautiful timber that's inside. That's part of. I think it's part of the building's presence, that everybody can actually see that this is a timber building and that timber is amazing. So by protecting the wood just by a skinny layer of glass, you could do that. And I think it compares with just a cladding of any sort. Yeah.
Other questions? Yes, straight up here.
And as a matter of fact, if I can add, there is a lot of reuse glass that does not embed a lot of energy. So reusing glass is also part of could also be a part of a recycling strategy. Okay.
Reduce, reuse, recycle. Hi, I'm Rachel, again, landscape architecture student. I wanted to ask about, obviously this is made for a university and it's made to be a place of learning. What overall, sort of tying back to Professor Rudzinski's question, do you think could be a learning experience from, if this building were to be built, what would be a learning experience for the community as a whole and for Arkansas as a whole, and even just for the university, or as grand of a scale as you want, really?
Well, I think taking part in the whole process is of course a learning experience, but I think that the importance in this building is of course that you can show that timber is a modern, it's a aesthetic, it's an amazing material, that you have the possibility of actually building a house that has a very, very low CO2 footprint, and that you could work sustainably also within a university building. I think it's a showcase, and it should showcase sustainability, but also wood. I hope Arkansas will learn that.
Yeah, I guess the only thing I would add to that is, well, a couple points I would add to that. One is that, we are hoping that for the greater Arkansas community that we can, help with this project to kind of expand the glulam capabilities in the area, and potentially, modify the design such that we can do that, or, evolve the design such that we can do that. I think I also mentioned an idea that would be very exciting of bringing some technology to site to showcase some of this CNC while the building is being constructed, and then that whole type of application is actually happening in the building as well, so it kind of continues into its actual use, and you can continue to see this type of fabrication happening, and the transparency of the space and the fact that the yard extends to the exterior really makes it something that is very visible to the community.
Further questions? No? It's a low glucose moment, perhaps. But Dorte and Michelle, if there are no further questions, there's a question from committee member Jonathan Bulkins.
Hello, I'm Jonathan. We had a conversation a bit earlier about your presentation, which is so beautiful. It looks so complete that I think it's really helpful for you to talk about how the building as a kind of flexible system that can be adjusted. And so, and in two parts, if you could tell us a little bit about the technology that you use to make it, for one, and then the second part is if you could talk about how drawing affects that technological process.
Mm-hmm. Well, I think this is a great subject to talk about. I could talk a lot about this because I think part of what I insist on in the office is that we have an analog and a digital process that is actually a parallel process every time we especially when we do sketch projects. I mean, when you go into construction drawings and everything, it's Revit. It's also a 3D process. But when you, in a way, try to understand space, I think that the analog model is a very, very useful tool. And at the same time, we use, of course, Rhino and Grasshopper and every digital tool we can get our hands on. So I think there's a great advantage in swapping between the two tools. And one of the things that the most important thing about the analog model is that it's not cheating you, and you are able to have a process with other people. So when you are in the digital process, you are only the person that are controlling the tool, and me standing behind pointing or something. So it's not an open process, and it's not a fast process in that sense. So I think that keep on using the analog tool because it's so much faster in some ways, but of course there are things it can't be used for, and I love Grasshopper also. We could never have done the Ilulisat project without. It's basically made in cardboard first, but then Grasshopper was very useful. So I think and I know there's a lot of tools to be learned, and I think it's very difficult for young students today to actually learn all these different tools. I think that the render tool is somewhat becoming, in a way, a little bit taking too much attention. I think that there are great tools like Enscape that you don't need to spend so much time on, but where you can see things sort of in 3D. But the renders, or the time we spend on renders, is just not worth it, I would say, but it's needed because otherwise we can't compete with other people that do even nicer renders. So there's and I think you have to be honest, I think it's a big problem because 20 years ago when I was starting with the, you could do sections and plans and everybody would understand. And today, not even really great architects can see a space from a plan and a section, right? Or you get lazy. You want to see a picture, and that means that you have to detail things that you're not even sure of. So in a way, it interrupts the process a little bit, and you see all these. They look finished. They're not finished, and they can change a lot. And I think it would also be bad if we could make a house in 2 months, but we make renders that looks like we've done it. So yeah, that's my that's the horse I ride on.
Okay. Any further questions? Okay. Dorte and Michelle, you both traveled long and far to be with us. In fact, we're going to welcome you back into our public lecture series, not too many weeks from now. But on behalf of the school and the university, we thank you very much for your work. We thank all 63 people there in Copenhagen. And I think there's several hundred Arab who stand behind you. We know it's a collaborative activity. We're very grateful for all the effort and commitment, enthusiasm. And the most I can say right now is we wish you well and safe travels home at this point. So thank you very much.